For introduction, let's move to the description of the Silver Bridge. The Silver Bridge was built in 1928 to connect the Point Pleasant in West Virginia and Gallipolis in Ohio. This bridge used an innovative I-bar chain suspension design instead of traditional wire cable. For event summary, this bridge was collapsed on December 15, 1967 during evening rush hour, and the failure caused by 0.1-inch crack in a I-bar. This case is important because it led to the Federal Aid Highway Act 1968 in the United States that mandated the regular and systematic bridge inspection. This is the timeline of the event for Silver Bridge. It started in 1928 and up to 1968. The Silver Bridge designed for lighter 1920s vehicles and pair of steel I-bar connected by large pins. So from investigation, the key facts are crack in I-bar 330 at joint C13N 0.1 inch deep, caused by stress corrosion and corrosion fatigue. Also, vehicle weight increase not accounted. We move to social and economic impact: 46 lives lost and family devastated, then severe community trauma and loss of trust in infrastructure. Next, we move to stakeholder involved. First, Ohio and West Virginia State Transportation Department, federal regulator, local government and maintenance contractor, and lastly, affected communities and families.
My name is Nur Shafika and I present about the engineering issues. First is the lack of redundancy in the Silver Bridge I-bar suspension design. Each link only had two I-bars connected by a single pin, so when one of the I-bar fell, the other couldn't handle the unbalanced load, causing it to fail and causing the entire bridge to collapse. So modern bridges now include multiple cables or support to prevent total failure from a single point. Secondly, an underestimated load and low safety factor were used during the design stage. The bridge was originally designed for lighter vehicle like Ford Model T back in 1927s, but by the 1960s, the cars were nearly 3 times heavier, which caused the outdated assumption meant the bridge was not strong enough for modern traffic. So third is the poor maintainability of the bridge. Critical areas like the I-bar interior were hard to inspect. Additionally, they only used visual inspection because NDT tools were not available yet at that time. A 2.5mm crack were undetected during inspection, causing it to grow over time and lead to the fracture of the I-bar. So these three issues stress the importance of redundancy, accurate load estimation, and easy inspection access in modern engineering design to prevent failure like this from happening.
So today I want to highlight the ethical reason behind the engineering failures. For the first reason is public safety. So many failures happen when safety is ignored for cost or convenience. Section 1.0 of the BM code states engineer must always put public safety first. And the second reason is lack of professional competence. Engineers must not work beyond their expertise. Section 2.0 and 2.1 remind us to take on only tasks we are qualified for with up-to-date knowledge. So the third reason is we're speaking about the risk. Staying silent on known dangers is unethical. Section 1.5 requires us to report risks that could endanger life or property, even if our advices is overruled. And the last one is honest reporting. Concealing facts leads to disaster. Section 5.3 demands engineers verify and report information truthfully to maintain public trust. Next, for our recommendation is we must enforce a mandatory inspection by registered engineers. So under section 71A, only professional engineers can legally perform engineering services. So this ensure inspection are done by certified experts and keep unqualified individuals away from high-risk structures. And the second recommendation is we limit design submission to those with practicing certificates. Section 8.1 allows only certified professionals to submit final plans. This improves accuracy and prevents flawed design from entering construction. Next, our recommendation is ensure accountability through disciplinary action. Section 15.1 FA empowers the board to act against engineers who are incompetent or negligent protecting public safety. And finally, our recommendation is we require independent safety checks. So section 10B mandates accredited checkers for critical structures, adding a second layer of expert review to prevent failure.
So next, for the conclusion, for the overall, the Silver Bridge fell because one part broke and there was no backup. And this shows why safety is important in engineering, and we must check things often and think ahead. And also in Malaysia, engineers must follow the law and work to protect people. So engineering means keeping everyone safe.